Welcome. In this session, we're going to walk you through the physical setup of your Bare actuators. To get your computer talking to the Bare bus, we'll be using the USB 2 Bare, our high-speed RS485 USB dongle. The USB 2 Bare uses a standard 4-pin male header. For the exact pin-out and onboard switch functions, you can follow along with the diagrams on screen right now. One thing to keep in mind for RS485 networks is termination. While not necessary for most standard setups, you might encounter communication noise if your signal cables are exceptionally long or if the network impedance becomes an issue. To keep your signal clean in these specific cases, we recommend adding a 120 ohm terminal resistor at the very end of your chain. The USB 2 Bare makes this easy with a convenient onboard switch. Simply flip it to on if you've added a resistor at the end of a long chain to balance the signal, or keep it off for your everyday short-range projects. The USB 2 Bare is versatile, but for optimal performance with Bare actuators, we recommend a baud rate of 8 megabits per second. It also supports 2 megabits per second if your specific application requires it. When it comes to wiring multiple actuators, simplicity is key. The best approach is a standard daisy chain configuration. As you can see in this diagram, chaining them together keeps your wiring clean, organized, and significantly more stable. To see this in action, look at the THEMIS arm, which uses a straightforward single chain of 7 Bare actuators, a simple, linear flow from base to gripper. For a stark contrast, to support its dynamic, low-inertia movements, Bruce utilizes a sophisticated wiring topology, moving beyond a standard serial chain. Look at the gray Bare actuators in this diagram of our Bruce robot's lower body. Communication is initiated through the standard A and B signal ports from the power hub directly into Bare 6. Instead of using a messy return cable, the signal flows seamlessly down the entire right leg chain through 7, 8, and 9, reaching Bare 10. Here, it leverages Bare's unique hardware. Bare 10 activates the dedicated, independent pass-through A and B channels for the entire return path. The signal then physically traces back exclusively through these pass-through channels from 10, 9, 8, 7, and back to Bare 6. Once it arrives back at Bare 6, it continues this dedicated path, bridging directly across the torso to the left leg through 1, 3, 2, 4, and finally finishing at Bare 5. This creates an elegant Pseudo Fork Chain that eliminates bulky extra adapters and messy return cables, ensuring maximum signal integrity and a remarkably clean, lightweight layout. You can freely mix different types of Bare actuators in one chain. But before you power up, remember these 3 golden rules. 1. Voltage check. Double check that every Bare is receiving its correct power supply. 2. Baud rate sync. Ensure every actuator on the chain is set to the exact same baud rate. 3. ID conflict. Most importantly, verify that every Bare has a unique ID. No 2 actuators on the same chain can share an ID. Finally, let's talk about safety. For high-power systems or robots operating around humans, we highly recommend connecting the ground and ESTOP terminals to a Westwood Robotics Wireless ESTOP module. This diagram provides a detailed walkthrough of the ESTOP connection. You can easily download the full wiring schematics from our ESTOP product page. Currently, we offer the Wireless ESTOP kit, the standard ESTOP kit, and various individual components. We recommend purchasing the ESTOP kit to take advantage of our bundled discount. This allows you to trigger a full system halt remotely, a critical safety layer for any complex project. In our next video, we'll dive deep into how to set up and benefit from this Wireless ESTOP module. Thanks for watching, and we'll see you in the next one.